Good day everyone, welcome to the third dimension. Today is our second video from our infographic series in which we are going to have an infographic prepared and we're going to discuss a small civil engineering topic. So in this video, our topic is what are the grades of concrete? This is the infographic that I have made and in which I've discussed a few small points, and then we have the table followed by a few small points regarding the grades of concrete. So firstly, what is concrete? Well, concrete is a hard mass which is made from cement, sand, aggregates, and water through a chemical reaction called hydration. The hydration reaction is mostly between cement and water, while sand and aggregate are sort of additives which are added to it for the mass. Concrete is divided into grades and their compressive strengths and the ratios which are used to make that mixture. The grade of concrete, as you can see in point number 3, is defined as the strength the concrete is going to possess on its 28th day after it's casted. And the process or the casting should be done under normal conditions, and the strength of concrete should have reached 99% of its ability. So the grade of concrete on the 28th day is the compressive strength which the concrete is going to have. The grade of concrete is written and represented with a letter followed by a number. In point number 4, as you can see, M refers to the mix and the number is the specified characteristic strength of a 150 mm work cube at 28 days. The compressive strength is expressed in MPa, or newtons per mm square, or megapascals. So this means that an M20 concrete will have a strength of 20 megapascals on its 28th day. And in this entire mixture of concrete, cement is the main binding material, while the other two are the regulators of the hydration process. So cement is the main binding material, while the sand, aggregates, and water, and specifically the water, are the regulating materials. So they're the ones that regulate the process and form the mass, the hard mass that concrete is. While cement is the main binding material. And similarly for lime concrete, lime is the main binding material, and for asphalt, which is used for pavement constructions, bitumen is the main binding material. So the overall idea behind concrete or asphalt concrete or lime concrete is basically the same. We have a binding material, and then we have our regulators or an additive that we have to add to it. So let's get down here. This is the table that we're going to talk about in a few minutes. The last points, as you can see, we have is that the water-cement ratio plays an important role in a concrete's workability, strength, and durability. The water-cement ratio is another very important point when making concrete, and it plays a vital role as far as the strength of concrete is concerned, and its workability is concerned, and its overall curing process and everything depends on the water-cement ratio. And generally on sites, it depends, but as far as I've seen, a 0.35 or 0.4 water cement ratio is considered suitable. So it has to be something similar, a 0.35 or 4 or close. And generally concrete has two main types of mixes. One is the nominal mix, which is used for buildings or roads or houses, or generally for less loads, for structures in which less loads are involved. And then we have the design mix, which is a lab prepared ratio according to the materials we generally have in the market. And this is used for special projects in which high amounts of or complicated loads are concerned, and for example dams and tunnels. So Nominal mix is for usual cases for normal loads, and design mix is a lab tested ratio used for special structures and special loads. So generally M30 above M30 is considered as design mix grades, and below M30 is the nominal grades. And in almost all cases, M20 is the one which is used for RCC constructions, as you can see on the last point, and M15 is used for planed cement concrete, which is PCC in which no steel is involved. So let's get to the table. It says concrete grades and mixed ratios. These are the mixed ratios we have. These are the concrete grades. And this is the compressive strength, which is in MPa and newtons per mm squared. These both are the same. Megapascals and newtons per mm squared. And we even have PSI, which is the American way of saying it, which is pounds per square inch. So for M5, we have 1, 5, and 10. 1 cement, 5 sand, and 10 aggregates. Sand is usually M stone, which is manufactured sand, as people call it on site. So even sand can be considered as fine aggregates in a way. So we can say that 1 cement, 5 fine aggregates, and 10 coarse aggregates. So 1, 5, and 10. Similarly, for M75, we have 1, 4, and 8. For M10, we have 1, 3, and 6. And for M20, we have 1, 1.5, and 3. And following on, we have M25, which is 1, 1, and 2, which means that 25 MPa strength is predicted on its 28th day if the concrete gains 99% of its strength. If it doesn't do that, then of course it's not going to be 25 MPa. And then we have the design mixes, which is anything above M30. M30 or anything above is design mix. And M30 would again have a strength of 30 MPa on its 28th day, which is the same as 4350 psi, pounds per inch square. And then finally we have the high strength concrete grades, which is M50 to M70. These are all for design mixes. So this was the table that we have, and we're going to continue this series, and next time we're going to talk about another small and a short civil engineering topic. So these were the grades of concrete, and thank you for watching.